Hello! It's me, or Alice, making a YouTube video about polynomials, okay? So, yesterday I had like a mustache going on and stickers, but didn't really turn out so good because my camera died. So, I'm here to teach you once again about polynomials. So, I'm going to step over to the board down there. No, right here, okay? And here it is. Polynomials by me. Music by Never Shout Never. And this is for Algebra 2. See, Algebra 2. Yay! Mr. Rosales. And Waffle says hi to YouTube. Hello from a text message. Okay. So we're gonna step over to the other side of the poster, and since yesterday we kind of started, hold on, find my pen. I'm just gonna really go over it again for you. And we're going to start off with general trinomials. So, here it is. And let's say that you have this problem right here. And so you have 4x squared. This was a minus 13 plus 3. But to make my life easier, I put plus negative because it makes me remember that a minus goes to a plus negative, or negative, yeah, anyway. So then, to me, you can do a guess check, but I kind of like the box theory better, like a lot better. So here it is, and you just draw a box. And after you do the box, you make a little X, and then you multiply 4 and the 3, which is the first and the last number, and you get 12, and then you get the middle number, and you put it down here. So then you have to find two numbers that multiply to the top variable up here, or whatever it's called, and then add up to this right here. And so I put 12x and negative 1x because there's a 2x here. So you have to make sure that divides equally, right? So then in the first little box, so here, you always put the first number, which is that one right there. And then on this one, you always put that number right there, which is 3, right? So then you just fill in, which you can just do negative 12x or negative 1x or negative 1x and negative 12x, but it doesn't really matter what you do. So here, if I can even get some room, I'm just going to put negative 1x. Then up here, I'm just going to put negative 12x. And from here, you're probably thinking, what the heck are you talking about? Well, anyway, from in this little column right here, you find the greatest common factor, which is just 1, or an x. You see it? So then you have your first start, right? So then from here you look what multiplies from 4x squared. What do you have to put to get 4x squared from x? So that's pretty much 4x. I'm going to write it real fast and I'll show you. Because if you multiply 4x plus x times x, you get 4x squared. So then down here, you have to find something that multiplies the x to equal negative 1x, which of course is negative 1. Then up here, you pretty much have to find what times negative 1 equals 3, which of course is negative 3. So then you pretty much have your pairs. See, here's 1, and then here's another. Okay, so that's a general trinomial, which if you really want to be technical, your little thing will look like this. See that? Isn't it cool? I'll even make a little star beside it. And then we got our perfect square trinomial, which is this thing right here. Now, yes, this looks really confusing, but just take it normal. I'm gonna change that to a plus negative, and then this to a plus negative, and then, okay, so we're gonna go ahead and fill out my first little square, and then the last one. Okay, and then I'm gonna do my little x, right? So then I do, this times this to get my top number, which is negative 42 x squared. And then my number down here is negative x, which, that could be a 1, which, yeah, everyone knows that. So then I have to find a number that multiplies to negative 42 and adds to negative 1. So I'm just gonna, try it and see what works. So at the end you should get negative 6x and negative 7x. So then you can come over here and fill out your little thing. X. Was it negative? No, it was positive. My bad. My bad, y'all. Okay. It was a positive. Ooh, okay. 6x and negative 7x. Okay. So, the GCF, greatest common factor, there's just an x. And then you have to, multiply something to that to equal that, which is x times x, because that gives you x squared, right? So then you have, 6x, but, what times x equals 6x? So, just duh, a 6, right? Oh, is she being stupid? No. Okay, anyways. So then, what times 6 equals negative 42? Which, of course, is negative 7. So, here you are again, and then here you are again, and you're done. So, let's do this thing so you can actually see how it looks like. Okay. And of course, okay, this is what we call our special cases. I'll write that down. Hold on, almost done. Special case. It's so beautiful, isn't it? Hold on, I'll put a big heart beside it. Special case. Okay, so let's say you have one of these things. You're probably thinking, what the heck is that? Well, that's a difference of squares. Okay, so you can see here that that 25 right there is a perfect square, because 5 times 5 equals 25, right? And then here you can see that Mr. negative 36 here is also a perfect square, because you can do 6 times negative 6, because the 6's thing, yeah. And then, of course, the x squared is kind of like a perfect square, because you can divide them into 5x. So instead of doing our regular little, box theory, oh look, I even wrote it here. You can actually just do a little small non-guessing, because you already know. So you're pretty much doing this, and then that. So pretty much you just go over here and you're like, okay, so what two numbers can I get out of here? Pretty much the square root, right? So what equals 25? 5 times 5. So you go to 5 here. Go ahead and make our two little things. And then you put a 5 right here, okay? Because 5 times 5 right here equals 25. And then you add an x to each because it's x squared. Okay, so what times what equals negative 36? Well, you know 6 times 6 equals 36, so, you just make one a negative. So one is minus 6, and one is plus 6. Oops, that's a 9. My bad. Okay, 6. 6. Okay, 6. So, at the end, you end up with this right here. Hopefully this time I won't get it wrong. Okay, so this is your answer again. See it? So today, I showed you how to do difference of squares, perfect square trinomials, and general trinomials. Here's the examples again. Not that one, right there. Yeah. And then this, the special case. Yeah, special. Gotta be special. What would life be without special? I have a feeling I missed something, but I don't know. But if you really want to take this one the hard way, like, here's the work down here. I did it because I figured some people would be like, well, I don't want to do that. I'm complicated. I want to do the box theory. So, boom. Here's the box theory. Here's 25 because of that 25. And then here's the negative 36 because of that negative 36. So then you multiply these two little guys right here. But, okay, here's the catch. You have to add, right here in the middle, a plus 0x. Because if you don't do that, then you're not going to get it right. So you come down here, you have your little thing, you have that filled in. So you go to this, make your little x. Oops. And of course, negative 36 and 25x squared equals negative 900x squared. And then, of course, we got our little 0x right here. So here it is again. So then, what times what equals negative 900, and what adds up to 0x, which is negative 30 and 30. And so then, you just fill them in. Greatest common factor, what times what equals that, what times that equals that, what times that equals that. And pretty much, you are done. So, don't get too complicated because it's really not. And do not fall in love with the box theory, or however you spell it. Because if you do that, then, instead of taking the easy way, special case, you're going to take the long way. And that is not good for the ACT. Right there, you see it? Anyways, so I want to thank you for paying attention, I guess, if you even watched the rest of my video. Okay. So, thank you, Ms. Rosales, for teaching me this factoring thing, or whatever it's called, the polynomials. Well, here it is. Polynomials. Okay, by me. Music by Never Shut Never. Don't pay attention to that. And then, this is for Algebra 2. Bubble says hi to YouTube. Not y'all, sorry. And here I am again. Thank you, and I'll see you in class.